Hello everyone, super happy to be here in the KubeCon stage. Welcome KubeCon, I'm super excited to be here in London, in my home city. I hope all of you enjoying the warm weather in April in London. So my name is Andrey, I work at Apple. I've been in this community for the last 8 years. Right now I'm the Kubeflow steering committee. So today we're going to share you the updates from the ecosystem at what's actually next for cloud native AML. And first of all, I think we'll spend a few minutes to introduce our panelists. So Yuki, you can start.
Thank you. I'm Yuki, software engineer working for CyberAgent and maintaining Kubernetes, Kubeflow, or Batch-related CNC ecosystem tools.
Hi everyone, thank you for being here. My name is Yuan. I'm a senior principal software engineer at Red Hat AI, and I'm one of the steering committee members in Kubeflow, and also a project lead for Argo, and also co-chairing the Kubernetes working group serving.
Hi everyone, I'm a technical director at Nutanix AI. In open source, I'm part of the Kubeflow steering committee and lead a couple of AI initiatives, training and AutoML, and also in ML common storage.
Hello and welcome. I'm Valentina Rodriguez. I'm a principal architect at Red Hat, and also I contribute to Kubeflow on diverse projects. I'm also part of the release team, and also work with the platform working groups, and I am a KCD organizer in New York. So thank you.
Thanks you. Please welcome these amazing speakers to the panel. All right, so let's talk about Kubeflow. So first of all, let me ask you, how many of you actually know about Kubeflow? All right, how many of you actually successfully run this in production? All right, I see a few hands here. So just to remind everyone, Kubeflow is an ecosystem of open source projects. So the goal of our community is to make it simple, to make AI and ML on Kubernetes simple, portable, and scalable. You can run these components in any Kubernetes cluster, whether it's on-prem, third-party cloud, or local machines. The beauty of the Kubeflow is composable platform, so you can use individual components as a standalone application or as a complete end-to-end platform. So this session will be focusing on GenAI and LLMOps, and our community in the quite recent years worked really hard to actually enable Kubeflow components for GenAI. And I think we can say that similar to AI and ML, right now we all live in this new world, and all these components actually, you can easily do GenAI and LLMOps with them. And we will share throughout the session how actually it's possible. So by the Kubeflow, you can think about like a bridge between ML and the cloud ecosystem. So we provide the simple interfaces for data scientists and ML engineers to leverage those advanced tools. So we will structure our session in a way that we're going to show you the lifecycle. So this is a GenAI lifecycle that our community maintains. And as you can see, Kubeflow has several components which actually address every stage of GenAI lifecycle, starting from Spark operator for data processing, the notebooks for model development, and trainer for fine-tuning and distributed training, Katib for model optimization, architecture search, KSERV for large-scale inference, and the Kubeflow pipelines, which stitch all these pieces together. Also, we have a model registry, which allows us to store metadata and artifacts and have a sort of pluggable system between it. So as you can see, this is extremely powerful because this is an extensible and a portable ecosystem, because organizations can take components they need and integrate it with their internal platforms. So let me first talk about notebooks and what kind of exciting dates we had there. So notebooks team worked super hard to enable actually notebooks 2.0. This is a new thing called Kubeflow Workspaces. This is like the snapshot of the new UI that is going to come up very soon. So the idea is to provide you simple interfaces how you can create interactive ID for data scientists using RStudio, VS Code, Jupyter Lab in a way that this is very pluggable for data scientists and at the same time for platform engineers. So if you want to learn about it, please join their community calls. There are a lot of exciting updates coming in, so looking forward to the release. Moving forward to the Spark operator. So the goal of Spark operator is to enable Spark applications on top of Kubernetes. We have a lot of organizations who are using this in production. Recently, this project got donated from Google to Kubeflow ecosystem. So right now, it's part of our broader scope. And quite recently, they released the new version of Spark operator, which is 2.1.0. They integrated new pod templates there to support Spark 3.x. Also, they've done a significant amount of work for Unicorn with gang scheduling. They refactoring the entire code base with control runtime. Also, like very exciting things about interactive sessions. So folks in the Spark operator community work really hard to actually enabling Jupyter notebooks works well with Spark on Kubernetes. So this is like very exciting things coming in. So if you want to join them, please join the community calls. It's like regular calls every, I believe, Friday, every second Friday. So community is great, and let us know if you're using Spark operator. We're looking forward to more organizations being involved. One of the very exciting things about Spark is actually benchmarks that AWS, friends from AWS have done here. So they actually tried to run Kubeflow Spark operator on 60,000 Spark applications across 36,000 pods, which was great. Like this blog post has a lot of great information of how actually Spark can be used at large scale. So it's amazing. Please take a look. So next. So next I'm going to speak about Kubeflow KT project. So as I mentioned, this project for hyperparameter optimization and architecture search. So I have a few exciting updates for GenAI this year. So this is one of the examples how we actually simplify hyperparameter optimization for LLM fine-tuning, which actually allows you seamlessly create experiments with KT using just one simple API. So this is actually one of good thing. This is was contributed by GSOC students with our community. So this is fully in upstream. So if you want to check this in the blog post, I strongly suggest you to check how we can make it easy for folks to do parameter optimization for LLMs. Also, one of the exciting updates about RAG. So actually, KT is kind of the project which allows you to optimize almost anything. And one of our contributors show how you can use this with retrieval augmented generation. So basically, they creating the entire RAG pipeline and plugin is within KT experiment. So they can see how this could be optimized within their lifecycle. So also, please feel free to check the blog post. It's really exciting things. Then I'm going to pass it to Yuki, so he will speak more about the Kubeflow trainer project. We have a lot of things there.
Thank you, Andrey. Okay, in my section, I will introduce about Kubeflow trainer. As described by Andrey, so in today ML workforce cycle, we typically perform the training, model training and fine tuning. After the model development, Kubeflow trainer is responsible for the fine-tuning and model training. Kubeflow trainer is actually designed for not only for large language model, so generic fine-tuning and machine learning training model. Across various frameworks, something like PyTorch, JAX, TensorFlow, or others. Kubeflow trainer, today we have Kubeflow trainer B2, and Kubeflow trainer B2 is role-oriented resource model, which means trainer has two types resources, which is train job and training runtime. Training runtime is predefined by DevOps engineers, and ML engineers define the train job, and they specify arbitrary training runtime in their train job. This model allows us to decouple responsibility between infrastructure side and training code side. By this resource model, by this resource model, data scientists can focus on their training code and related parameters like a number of nodes or number of processes inside of single nodes or something else. And this table is current machine learning frame supporting tables. As you know, we are planning to support various type of ML framework for Blitz, the same as B1 trainer. Currently, we support PyTorch, DeepSpeed, MLX, and the TensorFlow and Hugging Face is under development. Eventually, we support JAX, Paddle, and XGBoost. In this slide, let me quickly iterate our Kubeflow trainer internal mechanism. In the training B1, we have ML framework dedicated to CLD, something like Python job or TF job. However, in the trainer B2, we consolidate all kind of job CLD into training runtime and train job. So instead of dedicated job CLDs, we construct Kubeflow trainer pipeline framework only for internally. This allows to reduce maintaining CLDs and rapidly increase additional ML frameworks in Kubeflow trainer. Additionally, this allows platform developers to support arbitrary ML framework by themselves internally. Next, Andrey is introducing about user experience.
Thank you, Yuki. So Kubeflow Trainer is the next iteration of training operator for those who have been using there. So it has a lot of great features for GenAI. So one of the examples, this was a talk yesterday about distributed error cache for distributed ML training. So it is a very exciting project. So what we basically have done within the community, we connected those data libraries, Data Fusion, Apache Arrow, and Iceberg, and we bring them to Kubernetes. So the thing is, like, this is exciting work. We're going to give another demo today in the Kubeflow booth at 1 p.m. about it, but the goal is for us to actually create a distributed data cache on Kubernetes, which allows us to distribute streaming for the PyTorch. So basically, we kind of converting the Arrow format from Iceberg all the way to the PyTorch tensors, which basically allows us to do the zero-copy translation. We see a lot of improvements. We're constantly doing benchmarks. We're going to propose it to the Kubeflow community relatively soon. So please join us in the booth if you want to see the demo. It's like one of the most exciting work going on right now. Going next, so GenAI. So as I mentioned before in the panel, and many of us actually know right now, we try to see how we can simplify Kubeflow for ML users, specifically data scientists and ML engineers. So this is like one of the really exciting work coming in. So we try to provide unified Kubeflow SDK, which can allow data scientists to quickly process their data, train them, and optimize them. Everything in a single Python interface. So they don't even need to know anything about Kubernetes. So what we learn from our users, they want to still leverage Kubernetes to scale, but they don't want to learn Kubernetes. So Kubernetes kind of abstracted the way, you don't even need to understand kubectl or Docker or YAMLs. Kubernetes, they just focus on PyTorch, which they run it and then scale it. Exciting work coming in, new working group, ML Experience. We am happy to announce it. It will be in the Kubeflow community. If you want to join, please check this proposal in the community. One of the also exciting things about Kubeflow SDK, we collaborate with Llama Stack community. Because the thing is, as you can see during this session, Kubeflow kind of provide the end-to-end ecosystem for GenAI at scale. And we right now try to stitch Llama pieces and Kubeflow together. So folks who are actually using Llama in production, they can leverage the Kubeflow tools, so quickly build agents, do post-training, do evaluations, using the existing tools. So all of us not going to reinvent the wheel. Also exciting things about this TorchTune thing. So with SDK initiative, we collaborate with TorchTune community to create this fine-tuning experience when basically data scientists can simply use one train API with pre-built trainers, which we kind of pre-create. And all the things they need to do just need to, as Yuki mentioned, trainer has a concept of runtime. So we create a runtime where they can just pass it in their Python script. And this runtime has entire utilization for data sets, model utilization, and it has distributed training. So extremely powerful. We're leveraging Kubernetes for orchestration. We're leveraging TorchTune for PyTorch fine-tuning. So we don't need to, again, redo the same things all over and over again. And all of this, and Johnu will give a demo about end-to-end GenAI experience. So all of this allows us to construct the entire pipeline using the pure Python interfaces. So we have process data with Spark, we have training with Kubeflow Trainer, we have a serving with Kserve, and all this constructing end-to-end GenAI pipeline, which again, Johnu will mention about in this session. And it's super exciting, and it's great experience for data scientists so they can quickly do iteration at scale with leveraging all those advanced tools the community working with. So with this, I will pass it to Yuan, so he's back at model registry.
Thank you, Andrey. So Machine learning lifecycle and AI lifecycles are very complicated. So you can train the model, tune your model, experiment with notebooks and everything, right? How do we track everything, right? So the Kubeflow model registry was a project donated from Red Hat to help users manage and version models and their metadata throughout the machine learning lifecycle. It fills a gap between model experimentation and production activities, and provides a central interface for all stakeholders in the machine learning lifecycle to collaborate on machine learning models. So some updates from the model registry projects. So we introduced the model registry UI, so that's pretty neat, and it's much easier to use now besides the backend APIs and CLIs, right? So with UI, you can easily just click around and upload your models and do all sorts of things. So you can register models easily, and yeah, we also have updates to integrate with custom storage initializers as well, so that it can work well with Kserve and other projects. So there are other minor features and bug fixes along the way. And once you have the model, right, how do you serve it? So Kserve comes into play in this machine learning lifecycle to serve your models. So what is Kserve? Kserve is a highly scalable, standard, and cloud-agnostic model serving and inference platform on Kubernetes. Note that it's not only for predictive AI, but also for generative AI as well. Some updates from the Kserve perspective. So we added the integration with Envoy AI Gateway that provides support for multiple LLM providers and token-based rate limiting and routing with traffic shaping, fallback, and load balancing, and so on. So we've also improved the auto-scaling capabilities for large model use cases so that you can use you can do like auto-scaling based on custom metrics. This is through the KIDA integration with Kserve. And we've also added the model caching capability through PV and PVC, so that you don't have to download the model again and again, especially if the model is large, and it takes time to spin up the model during auto-scaling. And we've also improved the LLM serving runtimes. So we've added the multi-node inference support through VLM serving. So we'll continue working with the VLM community to improve the VLM serving runtime. So we also added support for gateway API integration. So especially specifically for the raw deployment mode, so that you can use it to use both ECTL and Envoy gateway as your gateway implementation. Next, I'll pass it to Johnu.
Yeah, you would have heard about all the components here. So Kubeflow pipeline is the last one, which is stitching all these components together. So if you want to orchestrate the entire workflow in a DAG or a graph, pipelines can stitch together. I'll show in the coming demo. So I'll just go with the demo. I think this will make things clear. So we'll take a minimal example here in the interest of time. So we'll take a Hugging Face Gemma 3 1 billion model, which is a very lightweight, a small model, which got released a week ago. And the idea is to create a fine-tuned model for reasoning. So you would have heard about reasoning. The idea is to understand how the inference output is obtained, right, using GRPO, using the unsloth library. So that the idea is to use the Kubeflow trainer for doing the fine-tuning, and once we have the fine-tuned model, use Kserve for the final inference. And the whole thing is stitched within the Kubeflow pipelines. So here is the default Kubeflow dashboard. So we have a default user, which is the Kubeflow user. You could, and this is based on the profiles. So you can switch between profiles if you have permissions to do that. So this is a multi-tenant system where you log in as a user, and you can, being an admin, you can always switch to other profiles. So on the left, whatever you're seeing are Kubeflow components. and the notebooks, Katib, Queso pipelines, you would have heard about all of that. And if you go to notebooks, you could create Jupyter notebooks or RStudio or whatever runtime that you need and specify resources, for example, right? And add storage and do your experimentation in the very first go. For Katib, you could add hyperparameter tuner optimization with various algorithms with your target and the objectives that you actually want to have. For your pipelines, you can create an experiment and associate runs. So run is a single workflow execution. You can imagine this to be like multiple runs within your organization, running graphs multiple times based on your requirement. So let's go to the LLMOps part using Kubeflow pipelines. I have a notebook here, which is already created. Going into the notebook, where I have a fine-tuning Jupyter notebook. Install KFP, which is the Kubeflow pipeline SDK. Used Hugging Face token for downloading the gated model from Hugging Face, which is the Gemma 3 model. So the idea is to wrap your training code. If you have, in the current experiment, we are using a custom trainer. So it is up to you. If you want to have a default experiment, you could use a TorchTune, which we talked about it sometime later. So use TorchTune if you want your library to take it entirely from the start to end. Or you could use, if you have a custom code, wrap it within your DSL component of KFP pipeline, and it will take care of that. So here I'm using Unsloth library here, where I specify the model name. And if you know GRPO, the idea is to create reward functions. So the better the output, you reward more. The output will get aligned to the direction that we are seeing. If your output is bad, you give negative rewards, which is saying that like you have to tune more, right? That's the GRPO. So idea is to give more rewards when you are formatting and the answers are right, and give penalty when they are wrong, right? And that's a very simple one. We'll share that so that like if you want to see what happens in the backend. So all the reward functions are defined, and we have the GRPO trainer from Unsloth, where we put all the hyperparameter tuning options. So if you want Katib to tune this, that's also possible. It's not shown in this demo, but all the hyperparameters can be tuned using Katib. And this is the main part, right? I'm using the train function of the trainer. So I've defined the train function, used the Kubeflow trainer to start training in a distributed manner. So here, if you see that, this is the core part, right? I'm saying I'm going to train this function on one node with 4 CPUs, 64 gig memory, and 1 GPU, right? So just change number of nodes or number of GPUs that you have in your cluster, and it will automatically scale up. And I'm waiting for the job to get completed, and once done, I delete the job. The second pipeline task here is the inference. Once I have a fine-tuned job, I will create a deployment from the fine-tuned model that is created from the previous task using Kser, right? And the whole pipeline is orchestrated using the Kubeflow pipelines, where I create the DAG here. I'm saying that the training has to happen after the storage is provisioned, and the serving has to happen after the fine-tuning is complete. And I'm triggering the fine-tuning here. So once the fine-tuning pipeline is created, you could go to the pipeline section, the UI, to see the progress. So you would see a new run here, which is triggered here, and see the DAG, which got created, right? I created storage. I have a fine-tuning step, which is happening right now. And once that is completed, it goes to the serving step. And there is a separate path which I've created for the original model to just do a comparison, serving of the original model. So you could see logs and all the other details within the UI itself without looking anything from the Kubernetes side of things. So the gRPO fine-tuning happens right now. So if you see the pod, you would see that there's a training pod which is created because we are using a single pod right now, but you can scale as per your requirements. And you could see that the train job, which is a CRD for running the training, right? And it is in created state. And there's a base model which got created, and that's the reason I'm seeing inference service from the base pod. So once it is complete, you could see that the training pod gets into the completed state. And the bottommost part was the pod for serving. So the fine-tuned model job was created, completed, and then it went to the serving state. So you could see that in the UI itself, all the steps are complete, and I'm ready for inferencing. And you could also see the same thing, all the KServe-related endpoint details from the KServe tab there to see what the endpoints are and how to send requests to that. Just to highlight here, so we used gRPO trainer, so you could also see that the rewards are getting better, so which actually means the fine-tuning is happening. So we did that for limited steps in the interest of time, but your rewards are getting better. So if you do it for longer time, you would get much aligned results based on your requirements. So you could get the infra side metrics as well. And we are ready for the final inference. So I am asking a question, what is the area of triangle for length 344, right? And I'm sending request to the hosted endpoint by KServe. And you could see that the model is trying to reason, right? Like from the site length that we have, it is trying to figure out what's the solution, possible solution that I have. So in a normal sense, you would see the final answer. The area of a triangle is 3 root 55 by 4. And between the start working out sessions, you would see how this is obtained. That's the whole demo.
All right, so I have 2 minutes to summarize everything. We'll do my best. But, well, thank you so much for staying with us on this. We have great news. So we have released Kubeflow 1.10 here at KubeCon a couple of days ago. So kudos to the team and everyone who contributed. Thank you so much. But yeah, we have many great things. So we talk about the UI already. We are also bringing efficiency and optimization and user experience with training operator distributed chat support. Also, we talked already about tips, I will skip it. But also for Kubeflow pipelines, we are doing many improvements to allow you from user experience, but also efficiency to control like resource limits management in the pipeline, but also for controlling the limits into the loop parallelism, so you can control the whole pipeline, the whole loop execution. So the other thing we have is also Spark operator is now part of Kubeflow, and we are working hard on security. So we have done CVEs reductions, but also we are looking into all components and looking into improving security best practices. This is the roadmap, so just really quick. Again, we are looking into many things from GenAI inference, support from KServe. We talk about trainer, user experience, pipeline security upgrades, and continue increasing the experience and also storage integration for model registry. But what is exciting is really about what this community is about. and it's about, we are working towards graduation right now. So it's a really exciting time in our community and everything around AI. So what we are doing is also all the working groups are coming together to build new working groups that we can work across the different components by bringing like data, focuses on data, and also better user experience across all those components. So the great thing about all of this is that we are a community that evolves, that brings new idea, and you can be part of it. So if you have ideas about any proposals, so feel free to submit it on any of these links. The other thing that we are working on is in our outreach committee. So we do need help on this, so please help us, join us. We are working also on Helm charts. So the idea is how we can make our deployment process for Kubeflow more easy for you by bringing the Helm charts into the picture for Kubeflow, the manifest projects and all the components, but also FIS, for example, who's been an add-on. The FIS community proposed to donate as a feature store to the Kubeflow ecosystem. So the last things, I want to invite you to join our community. This QR code, you can join. This is our Slack. Yeah. We also have meetings. Our meetings are amazing. So each working group meets and talks and discuss things. So you can be part of that. We are really looking forward to, decide the future of Kubeflow and AI. So let's do it together. Join our meetings. This QR code will give you more information. The other thing is the Kubeflow community call is the best way and the best the best way where you can start joining our community. Get involved. We have many social channels as well where you can follow us. And also we had many adopters. I don't know if you saw the keynote yesterday. It was amazing. So please join us. And we also have a survey. So we want to hear from you about your experience with Kubeflow. Maybe you are a new adopter. Maybe you are evaluating. We want to hear from you because it will help us to really start shaping the future, looking at what are the things that we can improve. And we want to do it with you. You are our community, so we really want to hear from you. And with that, this is my last slide. Just a quick question. How many of you are data scientists here today? Okay, how many of you are AI engineers? How many of you are platform engineers? Okay, great. Thank you so much. Please connect with us. Thank you.
Thank you. Feel free to ask any questions after the session. I'm looking forward to speak with all of you. And please join us. Let's not reinvent the wheel. Let's build things together. So thank you, everyone.